Factoring with GCFs, factoring by grouping, and difference of two squares. So this is kind of an introduction to many topics that you guys are going to do throughout the rest of your time at university. Every class will involve factoring. So I know this is something that's new for all of you. I'm guessing you did not do this in pre-algebra. Has anybody ever seen anything like this before? You did. Okay. So maybe you've seen a little bit of it. All right. So with numbers, numbers can be factored using a factor tree. So like 100, as I said, it breaks down into 10 and 10, and then 2 and 5, 2 and 5, right? So we can write its prime factorization as 2 squared times 5 squared. The same thing can happen with polynomials. So we can factor polynomials in multiple ways, okay? So the first method we learn is by factoring out a GCF, greatest common factor. So when you look at 15x to the 6th, y to the 3rd, plus 45x, y cubed, we look at our numbers and we say, okay, 15 and 45, what is their GCF? What is the greatest common factor? What number? 15, okay? What about the x's? How many x's do you have in common? If you had 6 x's lined up and you had 1 x, you would have 1 in common, right? And then the y's, y cubed and y cubed, we have y cubed in common, okay? So our GCF is 15x y cubed. So what we do is we pull that to the front. Okay, basically it's like we're dividing it out into both of these. So it's dividing in here, it's dividing in here. Okay, so if I take 15x to the 6th y cubed, so we did this before, and I divide by 15x y cubed, my 15s will cancel. How many x's would I have left? I'd have x to the 5th on top, and how many y's would I have left? None. That is what we're doing. We're just doing it in a different way. We're not writing out the division every time. Do you guys understand that? Okay, so what we do is we have our 15xy cubed, and then we need to multiply it back in. So we're saying if I was going to multiply this back in, I would have a 1, I would have 5 more x's, I'd have no more y's, plus 3, no more x's, no more y's. So that would be the final answer there. Does that make sense? Do you guys understand that? Did you all get that on your whiteboards? All right, so this next one. So we look at our numbers and we're like, okay, we have a 10, we have 15, and we have 5. So what's the GCF for the numbers? Do I need to call on you guys? Isabella, what's my GCF for my number?
For 2.
Yeah.
5.
Yep, and then how many a's do I have in common? A cubed, a squared, a. So I have 1a. And then b's, 1 b's, 1 b. So I get 2 a squared b plus 3 a minus b squared. Do we all have that on the whiteboards? All right, try 3 and 4. So try 3 and 4 along with me. See if you get exactly the same thing. Everybody have their marker out. AJ, try it. Try it again. See if you can get it. All right, so go ahead and try it. So we have a 3. Yeah, we have an a in common. I said do it on your whiteboards and see if you get it. And we have a b cubed in common. So when we do that, we can pull it out. I always say pull the GCF to the front, pull it out. And we have a, b, minus 4. What will I have here? A's and b's? How many b's? Nothing? Yeah, do you guys see it's nothing? Because we already have the a and we already have 3 b's. And then plus 8, a, b to the 2nd. Did you guys all get that? All right, and the very last one just has a GCF of 25, so we pull a 25 out and we get 4 plus 3x plus 2x squared. Okay, and that's kind of the most common one. Like you'll often see just a number that you can pull out, especially when we get to the trinomials that we kind of practiced yesterday. Okay. All right, so let's try a little bit harder. You guys are like, great. All right, so the next thing you're often going to see is what's called the difference of two squares. Okay, so a perfect square. Tell me numbers that are perfect squares. Write some down. What's a number that's something times itself? 25. What else? 4. 36. 9.
49.
16.
49.
49. 1. 81. 144. Do you guys all know these numbers? These are perfect squares, all right? So I could write them all down. I think you guys know them. Yeah, there's even, can you go even higher? Who knows something more? What was it?
257.
256. Ooh, that's good. You guys are good. All right. So if we see something involves square numbers. So 25, 16, 36, 49. If we see that, that's kind of a red flag. Ooh, let's look and see if it's the difference of two squares. What does the word difference mean?
Like the amount in between.
Difference? Kind of. Yeah, like the difference between like 10 and 12 would be 2, right? But what did I do with 10 and 12? I subtracted. Difference means subtract. So if you see a subtraction problem with perfect squares, that is the difference of two squares. Okay, so looking at this, it says x squared minus 25. If you FOIL out x plus 5 times x minus 5, do you guys remember FOIL? Whoops, my marker is not calibrated correctly. First, outer, inner, last. I gotta calibrate this, hang on. It's gonna drive me nuts. All right. 5 times x minus 5, and we FOIL it. Remember FOIL. This is multiplying a polynomial. Here's how we multiply polynomials, so Caitlin and AJ. If I have x plus 5 times x minus 5, it's related to the distributive property. You know how to distribute something like a 3, right? Well, with this, we distribute the x into both things, and then we distribute the 5 into both things. And we use a little shortcut. We call it FOIL, first, outer, inner, last. Okay, so first terms were the x times x. The outer terms were the x times negative 5. The inner terms were the 5 times x, and the last was 5 times negative 5. So we call that FOIL. Okay, all it is distributing twice. So the first thing we do is we take the x times x, and we get x squared. We take the x times negative 5, and we get negative 5x. Then we also distribute the 5. So 5 times x is 5x, and 5 times negative 5 is negative 25. So if I FOIL that out, do you guys see that we have x squared, negative 5x, and positive 5x go away, and we get minus 25. Do you all see that? Okay, that is what we call the difference of two squares. So when you have something like x squared minus 25, there's a pattern. We first recognize, oh, 49x squared. 49x squared is what times itself? 49 was what times what? 7 times 7, right? X squared is x times x. So I set it up, and I say, oh, I'm going to need 7x and 7x. So when I multiply my first terms, 7x times 7x, I get 49x squared. Max, Sarkis, you with me? Right. What about the last terms? The last terms need to multiply to be 81. And not just 81, but negative 81. 9 and 9, right? So I put my 9 and my 9 in those spots. But when I FOIL things out, I need for my outer and my inner swoops to go away, just like they did up here, right? The negative 5x and the positive 5x totally went away.
Can you slow down a little bit?
So if the negative 5x and 5x totally go away, see how they canceled and made 0x? That's what we want. We want them to cancel. So in order to do that, we're going to need a plus and we need a minus. Okay, let's FOIL it out and check. So let's do the double distributive property, right? So we're going to take the 7x times 7x. What do we get when we do that? We get 49x squared. That was our first term, right? First. Outer, our outer terms are here. So 7x times negative 9. Not 81. Negative 63x. Not there yet. All right, and then I have 9 times 7x. I see. So 9 times 7x is plus 63x. And then that was our inner. And then our last terms, 9 times negative 9. So AJ, it was negative 81. Do you see how the negative 63 and the positive 63 cancel out? That's how we're getting 49x squared minus 81. That's what we wanted. Okay, so we're doing the opposite of FOIL. We're breaking it apart into the two sets of parentheses. So our answer for this was 7x plus 9 times 7x minus 9. Easy enough?
Wait, so how did you get that? How did you know to start out with that 7x before you did all
Because 7x times 7x is what's giving me the 49x squared. Okay, is the next one, is it the difference? Shh, guys, difference. Is there a minus sign? Difference. Is there a difference? Yes, difference of two squares. 25x squared, is it something times itself? Yeah, 5x times 5x, right? 16, something times itself. Yeah, 4 times 4. So this is set up so it's the difference of two squares. So we automatically know how to factor that. We write our two parentheses down, and the two parentheses look almost identical, but one's going to have a plus and one's going to have a minus. So what is going to go inside those parentheses?
5x plus 4 and then the other one's going to be 5x minus 4.
Exactly. 5x plus 4 times 5x minus 4. Done.
Wait, 5, 4.
Because 4 times 4 is what gives the 16. Yep, you see it. And you can check. Do you guys want me to show you the FOIL step? So if I FOIL this out, my first terms make 25x squared because it was 5x times 5x. Guys, look up here. The outer is 5x times negative 4. That makes negative 20x. The inner is plus 20x. And the last is minus 16. Those negative 20 and 20 cancel, and we're left with 25x squared minus 16. Yes, Caitlin?
For one,
That's the answer, yeah. It's easy. You got it. We got this. That's the answer. And this one, this is the answer.
What time is
Right?
break?
Not anytime soon. All right, next up. So x squared plus 4, is it the difference of two squares?
No.
No, why?
Because one is square.
It's the sum, right? And try as you might, the sum of two squares does not factor. What do we call numbers that don't have factors besides itself and 1?
Prime.
Prime. So we write prime.
So then we just leave it as that.
Mm-hmm.
So
Okay, so let's guess.
Anything addition?
Nah, not anything addition. The sum of two squares. The sum of two squares does not factor. All right, now try this on your whiteboard. What are your guesses? What do you guys think? Like, if it was going to factor, I would think it's x plus 2 times x plus 2. Wouldn't you guys think x plus 2 times x plus 2 works? Yeah, go ahead and try x plus 2 times x plus 2 on your whiteboard. And do the thing where we multiply the x into both things, right? And then you multiply the 2 into both things.
Wouldn't it be x plus 2 times x minus 2?
Well, you can try that one as well. So try both. So try x plus 2 times x plus 2 and try x plus 2 times x minus 2. Will, you got it? AJ, this is what you missed, so pay attention. So if you're doing x plus 2 times x plus 2, we're going to take the x and we multiply it into both things here. We distribute it into both. And then we take the 2 and we distribute it into both. And we combine any like terms that we have. So when we do this, we get x squared. Did anybody find it? You should have plus 2x plus another 2x plus 4. So we end up getting x squared plus 4x plus 4. That doesn't make x squared plus 4, right? So what was wrong with x plus 2 times x plus 2? We had that middle term. We had an x term. They didn't go away. Now if you try x plus 2 times x minus 2, those middle terms will go away, right? So we would get x squared minus 2x plus 2x minus 4. Did you guys get that? So those middle terms do go away. But what's wrong with this? Why is it not x squared plus 4? There are not too many x's. It's negative 4, right? It's not positive 4. We had a positive 2 times a negative 2, and we got negative 4. We didn't get positive 4. Okay, so that is why the sum of two squares is prime. Because try as you might, it will not factor. All right, so this next one involves both things that we've learned so far. So first, do you see that there is a GCF? We always look for GCFs first. That's the first thing we learn with factoring. What do they both have in common? They have a 5. How about x's and y's? Anything? Do we have an x in common? No. Do we have y's in common? Yeah. So we have a 5y. So our GCF equals 5y. So we're going to pull out the 5y. And when we do, we have x squared minus, 5 times what gives 125? 25. Now this is now the difference of two squares. So just like with numbers, numbers, sometimes you try to factor it and you're like, oh, but now this number goes further, right? This goes further. So we continue to factor it. Okay, so the 5y stays out front. And how does x squared minus 25 factor? Who's got this down? Who has it? Ryan, do you have it down?
No.
X squared minus 25, it's the difference of two squares. Sarkis, what do we think?
No, I'm not right. I was wondering on number 4. Shouldn't the 5, like, where did you, like, why is the 5 still the 5? Or, wait, no,
The 5y, why is it still up front?
Is it because you're factoring it into?
I'm trying to factor it. It's like I'm doing a giant factor tree. And so I pulled that out, and it continues to drop down, drop down, drop down. Yeah.
Is it x plus 5 and x minus 5?
It is x plus 5 times x minus 5. Perfect. Do you guys see? And that is the final factored form. Done. All right, and then the last method we're going to learn today is called factor by grouping. All right, the way that you can tell you're going to factor by grouping, will you with me? Is if you have 4 terms, or 6 terms, or 8 terms. So if you have an even number of terms, okay? besides 2. It gets 2, look for the difference 2 squares. Usually in Algebra 1 it's going to have 4 terms, okay? So we have 4 terms here. And I always call this split the middle. So factor by grouping, I always say split the middle. So what are we going to do? We're going to split it right down the middle. And I'm going to go right in front of that sign there. So I went right in front of the plus. And I'm going to ignore that 2x minus 12 right now. So don't cross it out, but I'm going to kind of say, okay, I'm ignoring that part right now. Then I do the GCF method. So with x cubed minus 6x squared, what do I have in common? What's the GCF? It's x squared, right? 2 of the x's. So I pull out an x squared. So I'm going to have x squared. What will I need inside the parenthesis when I pull out that x squared? X minus 6. Do we all see that? So if you multiplied x squared back in, you would have x cubed minus 6x squared.
But I don't see how you get this exact.
6x squared.
X minus 6.
Because if you multiply this x squared back in, you get x cubed, right? And x squared times negative 6 gives negative 6x squared. All right, if you do factor by grouping correctly, you will always, whatever you had in parentheses right here, you'll have over here. Is there a magical number that I can pull out to have x minus 6 left? A 2. Do you guys see it? Basically, you're saying, what's the GCF over here now? Right, I have 2x minus 12. What's the GCF? It's 2. And when you pull out a 2, you have x minus 6 left. Okay, I always say pull out a number and a sign. So not only just 2, I'm going to pull out a positive 2, right, plus 2. All right, so here's the weird part. Now this whole thing has a GCF. It has something in common that we can pull to the front. I've underlined them with my little squiggly lines. Do you see that they both have this common factor of x minus 6? Right? So x minus 6 is now a GCF. So what do we do with GCFs? We pull them to the front. So we're going to pull out that x minus 6. And when we do, the thing that's left is x squared plus 2. And we write that inside of parentheses. So we write x squared plus 2. That is our factored form. Done. How do I know x squared plus 2 doesn't go any further? Is it the difference 2 squares? No, not a difference because there's a plus, and 2 isn't even a square. So I'm done. But we always look for things like that. All right, I'm going to send you on a break really quickly.
Wait, this is cross-linking.
All right, so sometimes, oh, what do you mean, Sarkis? Sometimes you have a combination of factoring. So like we did the one where we had the GCF, right? And then we did the one where, so once we pulled the GCF, then we had the difference 2 squares. This is similar to that. So we're going to do our factor by grouping. But once we do our factor by grouping, maybe it goes further. So we're going to look and see if it goes further. All right, so here we go. So we're going to split the middle. So always go in front of that sign right there. So I have x cubed minus x squared. And if I have x cubed minus x squared, I want to know what they have in common. They have x squared in common, right? So I'm going to have inside x minus 1. Do we all see how I got the x squared and then x minus 1? Imagine multiplying it back in. Right, you'd have x cubed minus x squared. So you're dividing by x squared for each one. Okay, so the next one, I have negative 25x plus 25. And I told you, I said, if you do factor by grouping correctly, the parenthesis part's going to be the same. So a lot of times I just have my students write that x minus 1 down, and then they think, okay, what do I need in order to have negative 25x plus 25? What number and sign is out front? So looking right here, if I have negative 25x plus 25, 5 squared, which is 25, right? So it's going to be minus 25. Do you guys see how when you have negative 25 times x, I get negative 25x. Negative 25 times negative 1 gives me plus 25. Do you see that? Oops. All right, now I have a GCF. The thing I have in common now is x minus 1. So with GCFs, I pull GCFs to the front. And I write x squared minus 25 in parentheses. All right, Xavier, what do you think with x squared minus 25? It's what? X minus 5 times x plus 5, right? Because now this is the difference of two squares. And then we're done. Okay, so we have it fully factored. All right, so you're going to have something like that on your homework where you have to keep going until it's all the way down.
How do you know when you get all the way done?
Usually it's like x to the first, and there's no GCF in any of those parentheses. See how you have like x minus 1, there's nothing you can pull out. X minus 5, nothing you can pull out. And then if it had something that says like x squared, always look for that difference two squares. But since these are x to the first, it doesn't go down any further. All right?
Still confused.
All right, so let's try this one. So we'll do one more where it keeps going, and then I'll have you do the next one as well. All right, so I have 4x cubed plus x squared minus 4x minus 1. So we split the middle. All right, so I pull out the GCF. I pull out an x squared. When I do that, think about what you have in parentheses. So if I had 4x cubed and I divide it by x squared, what's left? 4x, right? So I need a 4x. If I take the x squared and I divide by x squared, what's left? X squared over x squared is 1. A lot of people will forget that 1, but you need it. You guys see how if you multiply back in, x squared times 4x gives us the 4x cubed.
Where do you get
This one right here.
I know, but where do you get
If I'm multiplying back in, check. If I take the x squared in, x squared times 4x is 4x cubed. X squared times 1 gives me the x squared. I need that 1, otherwise I don't have the x squared, right? All right, so over here, I know if I do it correctly, I'm going to pull something out, and I'm going to have 4x plus 1 left. Yep, do you guys see that it's negative 1? If you have a negative 1 and we multiply it back in to check, we have negative 4x minus 1. That's what we wanted. So now we have our GCF of 4x plus 1. So we pull that 4x plus 1 all the way to the front, and we're left with x squared minus 1. Since it's an x squared, we say, oh, well, does this go further? Is this the difference of two squares? Caitlin, you with me?
X squared, yeah.
If it's x squared and it's minus something that's a perfect square, right? So see how that's a difference? There's a minus in between. And x squared is x times x. And 1, is that something times itself? It is, right? 1 is what times what? 1 times 1, right? 1 times 1 gives you 1. So it's still the difference of two squares. So it still goes down further. So it breaks into x plus 1 times x minus 1. And we still have that 4x plus 1 out front. It's just like a factor tree. We just pull down the factors that didn't go any further. All right, if you can do number 4 on your own, you'll be good to go for your homework. Do you want to try it? All right, so try it first. All right, so if I have 8x squared minus 4x minus 2x plus 1, what I was saying is we split it down the middle, so go right in front of that sign, and momentarily we just we ignore this part right here. And we're like, well, what's the GCF if I only had 8x squared minus 4x? So do you guys see what the GCF would be there? The GCF would be 4x, right? For this side. So we're going to pull out a 4x. So I'm going to have a 4x, and then I'm going to have inside parentheses what I need in order to get 8x squared minus 4x. So if I had 8x squared and I divide by 4x, I'm left with 2x. And if I have negative 4x and I divide by 4x, what do I have? Negative 1. Do you guys see that? And you can check, if you multiply back in, 4x times 2x is 8x squared. 4x times negative 1 is negative 4x. Okay, so we have it. Now we focus on the right side of the equation. Okay, so if I'm looking at the right side of the equation, so I'm temporarily kind of ignoring what was over here. So if we ignore that, if you do factor by grouping correctly, this is the part that many of you guys were messing up on. If you do it correctly, the part that's inside parentheses should be identical if it's going to factor by grouping, okay? So go ahead and write that 2x minus 1 down and just say to yourself, well, what do I need in order to get 2x minus 1? What do I have to pull out from here? I need the negative 1, right? It's always a number and a sign. So like Tessa did it correctly, and Tessa was like, oh, it's just a negative. And she put the negative, but then like she got to the part where she needed to write the 2x minus 1 out front, and she was like, I don't know, do I have like 4x negative? Like, so that's why you always have to pull out a number and a sign. So you need a -1, okay? So it's going to be 4x minus 1 left, and that's our answer. That's what we write it as. Okay, the reason this works is because you guys know how 4x, let's say I had w, minus 1w. You know how to do the GCF thing there, right? What would the GCF of this be? 4xw minus 1w. What would it be? What do they have in common? What variable? W. And you'd be left with 4x minus 1. That's the same thing that we're doing here. This is kind of like our w. We pull the w to the front, and inside parentheses we write 4x minus 1. Okay, that's all we're doing. It's exactly the same. So we factor the common factor to the front. All right, so shall we try some problems on your whiteboards? You guys want to try a few more, or are you just ready to try your homework? What do you want to do?
Homework.
Homework?